So who of you know Vantage6 already? A few of them? All right. Well, I'm going to give a short presentation. You can't cover everything, but I'll do my best to show the basics. I'm Eva Mezei. I'm a project manager at IKNL. My colleague over there is also working with me. And I work mainly on projects that use Vantage6 somehow. So the outline of today, I'm going to start with an introduction first. Then I'll give 2 examples of how Vantage works. I think that always makes it a bit more intuitive. The infrastructure components. So Vantage6 consists of 4 main components. I will briefly explain them. User experience. How can you use Vantage6? You can use notebooks or Raven, a very cool UI developed also by IDEA4RC. The risks in using the platform, the community, projects, and then something about future work. Where do we want to go with Vantage? And unique selling points. So first, the problem. More data, more power. Combining data from different sources is important for data science. So what does that mean? Of course, now with the rise of AI, you really need a lot of data when you want to build models, right? You can't, and especially with a domain like IDEA4RC, where you deal with rare cancers, it becomes even more important to use data from different sources. So more patients and more variables allows for better predictions. So if that's the problem, what's then the solution? And I think we have 2 main ways to do this. So the first one is the more traditional approach. So everyone who did data analysis, I think, knows this. It's a centralized approach. So you go to every hospital, you collect your data. Sometimes you even have to go there yourself, and then the data basically travels to one central place, and as a researcher I can run my analysis on this data. The second approach is federated data analysis. So the difference is that instead of the data traveling to one location, only the insights travel. So what are the main challenges? I think centralized data analysis is fine, it's a good way to do it. However, you have to think about a few challenges. So first, there's logistics. So I actually remember when I had to do my bachelor thesis, I had to go to Australia to get the data. You can imagine if you want to do that with 10 countries, it's not really feasible, right? So this is the first challenge. Then more, I think everyone knows this, privacy and security. So you deal with very sensitive data, patient data. You don't want any unauthorized person to have access to the data. Related to this, laws and regulations. You're not always able to share the data. You need to deal with GDPR and other regulations, and repetition. So whenever you want to add a new variable, you need to run everything again. That's not really practical. And finally, loss of control. So I also hear this a lot in hospitals in the Netherlands. They don't feel comfortable sharing their data because when it's out there, you lose control. So does this mean that federated data analysis solves everything? Well, it might solve these problems, but it comes with its own set of challenges. So it's a very emerging technology, and because of this, there's limited expertise and limited understanding within the data centers itself. Also, you have to deal with multidisciplinary teams. We also see it in this room, right? Kind of a lot of different people. But also for the software, where normally you only needed 1 data scientist, now you are dependent on the IT people, security, and all kinds of other people in the hospital. This also requires coordination, not only within the hospital, but also from every party. Whenever you want to add a new research question or add a new variable, every party needs to coordinate and actually perform an action to do this. And finally, investments, not only to deploy the system, but also to maintain it over time. In IDEA4RC, we use Vantage6 as one of the building blocks, and we extended Vantage6 in several ways. And I think it's really cool because, at IKNL we developed this software, but from projects like this, we learn a lot on how we can make it better. First, data harmonization. So, like Unai also told you, when you want to do federated data analysis, it's really important that the data is standardized, so it looks the same at every hospital. So data standardization. And one way to do it is by using OMOP Common Data Model. And now we're able to connect Vantage6 to OMOP as well. The second one, federated data preprocessing. So like when you do normal data analysis, you want to be able to pre-process your data before. And we added some new features, so now we can able to create new variables by exchanging the old ones, combining them, stuff like that. And finally, and I think this I like the most, tailored user experience. So within IDEA4RC, the Raven platform was designed, and it really gave us insights on what researchers look at when using such a complex platform. And I will give you an example later. So, 2 examples of how Vantage6 work. The first one, calculating the average age of patients with breast cancer across 3 different hospitals. So average age is very simple, of course, but I like to show this example always because it really shows it's not only a black box and we can understand what's happening. But you can make it as difficult as you want. You can also train AI models if you want to with Vantage6. So first, calculating the average. I'm a researcher at IKNL and I want to know the average age of patients with breast cancer across 3 hospitals. What do? I send my query, computation, how you want to call it, to the local datasets in the hospitals, and I get back the average age of my patients and the number of patients I have. So where normally you would get record level data, patient A, 62, etc. Now you get the average age and the number of patients, and in this way you can still compute the federated average. Now another example, I'm a data scientist and I want to predict the length of stay in the emergency department for patient X. I have again my model in the hospital, a lot of information which is relevant, and the model can learn across different hospitals, so it aggregates the model parameters. And now when the model is trained, you can apply it to a new hospital. So also this you want to do because you want to generalize, right? If you want to apply it in multiple hospitals. The infrastructure components. So I'm not going to go into too much detail, but the main components. We have a researcher, client, who asks those questions. Then we have the central server. So if I'm a researcher at IKNL, it would also make sense to put the central server, I think, at a neutral party. So for instance, IKNL. And the central server facilitates authentication, authorization, and communication. So no computation takes place in the central server. Then the nodes, they have access to the data and execute algorithms. So they are mostly located in hospitals, I would say. And finally, the algorithms are encapsulated in Docker images, like Eugenie also said before. You can use Vantage6 by using Python or R. I think Python is mostly used. But now we also have the Raven user interface. And the reason we wanted something like this was also that we noticed that only people who had some programming experience were actually using Vantage6. So our colleagues from IDEA4RC really had a lot of interviews on what do people need, what do they look at when using such a platform. And now you can see that you define different steps. So you basically start with a cohort selection. I want to include this hospital and that hospital. I want to include those variables in my study. And then you want to also see data quality. Perhaps if there's only one patient in your hospital, you don't want to include it, then you get record level data anyway. Or you want to say this hospital has too much missing values, let's not include that one. Then we have data preparation, so the pre-processing steps I mentioned before, basically. A list of algorithms in the 4th step. So after you selected your cohorts, you want to also select, for instance, logistic regression for my list of algorithms. And then finally, the results. So descriptive statistics, a bar chart, confusion matrix. And we mostly see that this one is the most important part, right? How you visualize the results afterwards. When dealing with such a complex system, that's fine. You also need to think about how the system can be attacked. So what we did is try to identify at every level, every component, what can happen, and more importantly, how we can mitigate those risks. For this, we have basically 2 documents, security and privacy analysis. It contains a lot of details on every component, where the computations take place, and where potential hackers can attack it. It's of course confidential, And even more important, we describe what data centers can do to mitigate those risks. And the second one is the DPIA. This one is open to share with everyone. It's a formal compliance, so in the Netherlands, when you deal with software components, it's really important to have this. You want to show also that you took all the right steps. Vantage6 also has a large community. So first we have the users that run projects with Vantage6, so without them there's no need to further develop Vantage6. Then we have also quite a big scientific community, so within IKNL there are 30 publications now, but I think also more external. Last year we did our first Vantage6 workshop, where we basically, with algorithm developers, looked at the source code. We showed them how they can set up nodes, run algorithms themselves. Then we also have bi-monthly community meetings with algorithm developers and infrastructure developers. And we partner up with those 4 organizations. So the eScience Center, Medical Data Works, IKNL and Mastro. And what I really like about Vantage6 is the tools. So everything is open source and completely free to use. So it's very transparent that way. Current projects we work on. Now, of course, IDEA4RC I don't have to mention. But there are 2 other Horizon projects, Strong Aya, improving the future of young adults with cancer. And also a new project called Protect Child, where we improve pediatric transplant outcomes with genomic data integration. And I also wanted to mention a natural project we do. So I think for this natural project called Platform for Reuse and Exchange of Clinical Data in the Netherlands, we also use Vantage6, and we installed it now I think in half of the hospitals in the Netherlands. And one of the use cases we have is that we try to predict ICD-10 codes using AI models from discharge notes. And also here, both the data, so every clinical node we use, as the outcome, the ICD-10 codes remain in the hospital. But there are and were many more projects, and we also hope, of course, that we can keep doing projects like this. I always want to show this picture because I think it's really cool that Vantage6 already installed through most of Western Europe and some instances in Asia. I think now we have 100 instances running across all the projects we do. So does this mean we are finished with Vantage6? Not at all. Vantage6 is still very much in development, and for instance, like I said, from doing projects like IDEA4RC, we really learn what we need to develop. So not only from a developer's perspective, but more from a user perspective. For instance, the metadata layer at IDEA4RC also really showed us what researchers need prior to the analysis. They want to know how many patients are in this cohort, in this hospital, stuff like that. From the Raven UI, we also learned what researchers need when they use the platform. And finally, in the future, so we already made the connection with OMOP, but we want to extend it, that we are also able to do this with FHIR. So why should you use Vantage6? Like I said before, everything is open source and free to use. So it's not a commercial party, we really want it to be out there. It's a container orchestration for privacy enhancing technologies, difficult word. It's extensible to different data source types, so CSV, SQL, OMOP, doesn't matter. You can use algorithms in any language you want, Python or R, or the Raven user interface. And you can easily connect to other applications using the API, so for instance to Raven. That was it. Forgot a thank you slide, but thanks for your attention.